So thank you everyone for coming to the 6th workshop in this series. So we're all really excited to have you and excited to have everyone persist along with this. So when we put together the idea of having 6 workshops on data standards within the vineyard industry, I think there would have been people that thought, I don't think I'm going to stick around for all 6. That doesn't sound very fun. But thanks to Ollie and Elizabeth and the team, we've managed to put together a really interesting and engaging session. And we've really come a long way. So thank you everyone for being a part of that and sticking with this, because it's important foundational building blocks. So today we're kind of getting into some of the tech a little bit more. How we practically enable interoperability was definitely one of the challenges that we set at the start of the project. So the key data sets, the mapping layers, things like block boundaries, how do you start to share those between different applications? How do you know if they're accurate? How do you update them? How do you change them? So that search has led us to the team from Koordinates who are speaking today. And thank you to Joris from Integrape in New Zealand, who are part of our community, who looped us together with them. Coordinates uses open source software, so that really fits into this approach of open knowledge and open code sharing, and the spirit that we have really wanted to bring out through these workshops. So we wanted Coordinates to share what they're working on and how they could assist us in the wine industry. So they have a combination of over a decade of learning and experiencing the challenges around mapping interoperability and managing big data sets, big geospatial data sets. Also thanks to Hans Loder at Penley Estate for kindly sharing his vineyards data for the demo. And as we go along, please feel free to ask any questions and we'll post them in the chat in Zoom, or if you're in Zoom, please post them in the chat. Eli and Ed, over to you.
Thank you. Eli, if you wouldn't mind sharing your screen.
Sure.
Okay, we're good. Good morning, everyone. I'm the CEO and the founder of Koordinates, and with me today are Eli Chadwick, sales engineer, and Anne Harper, business development manager. We're dialing in from different parts of New Zealand. Anne and Eli from Auckland, and I'm in a little area just north of Wellington. Next slide, if you could, please, Eli. So we have a pretty focused mission. We've been following it for 11 years now. We are making geospatial data available to professionals and field workers and scientists and decision makers. And that's really how we got in touch with Joris of Integrape that was mentioned just before. In his business, trying to integrate geospatial data further and better from your sector into his own products and services. If you move to the next slide, Eli. Since we were founded about 11 years ago, we've been on the outside or involved in a number of data collaboration projects. Most of them, sadly, I would describe as failures. They may have had results that came out the back end, such as a functioning data sets, but you couldn't describe the project process itself as being immensely successful. And that's a mixture of government projects, private companies, councils, county type thing, and some non-profits. If you could move to the next slide, Eli. So our main business in that decade was what we call data publishing, and that's the process of getting geospatial data on the internet. Heavily, that's a mapping agency type thing. I'm sure there's many examples in Australia, like Geoscience Australia. And we've been observing these collaboration failures throughout that time. And around 2 years ago, we realized there's a big opportunity to build some new tech that could remove some of the problems. So I thought I'd summarize the 3 key lessons that really flowed out from what we've witnessed on how collaboration projects around geospatial data have sort of worked for the few that sort of progressed through to working projects, and what we identified as the biggest blockers. So the first key lesson is that all of the projects that resulted in some sort of useful outcome had the ready and willing moving early on. I know there's a lot of tendencies to try and have some sort of committee, everyone agrees on a process forward, but unfortunately that means that momentum doesn't really start early on. Participants get a bit frustrated or move on to other projects. So that's our first big lesson. The ready and willing need to be able to move on quickly, start quickly. And that's been a fundamental part of what we have been working on that will be shown to you in a few minutes. Second big lesson is that there's just some fundamental technology blockers that exist right now. And then in the interaction, it was mentioned, you want to be able to move geospatial data between different relational databases and different GIS software and into different web applications. Really, the technology for doing that hasn't really existed. You need to be in the same organization, accessing the same systems to solve that sort of problem right now. Or you're using some sort of awkward collaboration mechanism for one of the GIS clouds that exist. I won't mention any of the vendors' names. The third lesson is that for many who have been asked to participate in collaboration projects, the cost side, which may be time, product, services, doesn't often relate well to the value payoff they see. And what I mean by that is a small business in an industry association or a sole trader or an app developer doesn't see the same value payoff versus the typical cost structure you see in the geospatial sector at the moment. And we have put a lot of effort as well into addressing that. In other words, pricing dropping through the floor so that the cost side is no longer a factor. Eli, if you can move on to the next slide. So Eli and Anne are going to show you a demo of what we've been working on, and it's essentially big parts of it are brand new. You are some of the first people to be shown it. It comes out of beta in a few months' time, and Eli and Anne can talk a bit more about that at the end of the demo. Anyway, Eli, take it away.
And just really quickly, sorry, Eli, I was just going to say, anybody in the audience, as these guys, because it's meant to be obviously quite a dynamic, interactive presentation. Yeah. So if you've got any questions that come up as they go, please feel free just to pop your hand up. I'll pass this to you. Also, if anybody on Zoom also has a question, please pop it on chat and either we'll bring you live to air or I can ask a question on your behalf. But please ask questions as they come up. So yeah, please feel free to ask as we go. Thanks, guys.
Cool. So I'm going to take you through the Koordinates platform and firstly show you how you would get data onto the platform, and then I'll show you how a consumer might get data off the platform, and then after that we're going to go to this new distributed version control system that we've put together for geospatial data. So this gives you an overview of the platform. Represented in the middle here is the Koordinates cloud. Over on the left we've got a number of customers. Our principal, our primary customer has been LINZ, which is the New Zealand equivalent of the PSMA. We've been running their data service for a number of years. We also have another Stats New Zealand and some other central government agencies. A bunch of corporate customers, Integrate, Yoris notably, and all the way down to small consultants and individuals. The thing that they all have in common is that they want to share their data on the internet in an easy way that doesn't involve taking custom data requests. And then at the other end of the pipe, we've got 120,000 registered users that come to the platform to pull down data from all of these publishers and more. You can also set it up in a small closed environment, so you can have group access to your layers. You don't have to make it open. We fundamentally are an open data platform. So I'm going to start by showing you how you would go about getting your data up onto the platform. So this is the landing page for Koordinates.com. Assuming I'm a publisher owner, want to get my data up there to share with other collaborators or users of the data. So I'd come in here and I click on Manage. This takes me to the data management section of Koordinates. First thing you're going to want to do is set up a team. You can have multiple teams that are viewing data. You can set them up with different access rights. So you'd come in here, create a new team. Let's just call it the GIS team. Once you've created the new team, you can come in and add a number of members. These are all people that have Koordinates IDs. So you can keep it to a small group, large group, whatever fits your business requirements. Once you have configured your teams, you can come into the upload section. This is where you get your data onto the platform. We support a number of different methods for ingestion. So firstly, if you have your data sitting in an Amazon S3 bucket, we can pull from there and do constant scans of it to pick up updates. If you're an Esri shop and you are through an ArcGIS server or enterprise implementation, we can do a scrape of the ArcGIS REST endpoint that'll pull a cache of the feature service onto the platform and make it available to a wider audience. We also support SIFs, Postgres, and WFS. So there's a number of different options for how you ingest data. The method I'm going to show you today is one of the probably the more common approaches, and it's where you simply have your data zipped up in an archive, select that. I can assign that to a team, it's a GIS team, and hit upload. So this is now copying the data up onto the platform. The site will then do a scan and look for any GIS data that might be inside of the archive that you can create a layer of. That is happening now, and it has been happily uploaded, and we can see that my zip file exists, and clearly it has GIS data in it, so it's available to create a layer. From here, I can click import, and now I can go through and configure what the layer will look like to end users. So here's where you'd put descriptive data about what the data layer is. What this is it's a layer containing the OpenStreetMaps vineyard land use information. Down here, you can tag the data out. So you might put in vineyard. The idea here is you want to put as many tags in as possible so that when users are searching for data, it makes it as discoverable as possible. Down here, you want to assign it to an owning team. This is the team that's going to be responsible for administering the data. You can add a category. This is handy. It groups like data sets together. So when people data, they'll also find other data that's of a similar type. It's important that you set a license. We support Creative Commons licenses, and by default, it's set to the most open. You may have commercial constraints, in which case we can accommodate any combination of things that you want to do there. So now we get a summary of what's about to happen. The system has discovered that you've got vector data in there. It's of type polygon, gives you a feature count, and it shows you the coordinate reference system. You can come down here and edit the columns. Perhaps you don't want to show all the columns. You can, from here, remove any that you don't want. And then once you've done all of that, you can click import and publish. So this is now going to copy the data, create the layer, and it'll make it available on the internet. Rather than waiting for that, I'll show you what a layer looks like that's already been created. So here's the same layer that I'd already uploaded. In here, you can set your access controls. I've got it set to anyone can view, no other access. You can set it to register to download. Apply. The other thing here to notice is that when the layer first gets created, we apply default cartography to it. In the event that you wanted to put custom cartography in, you can come down here and create a new map style and look at what that looks like. We support Carto CSS, so you can do a number of different things in here. You can apply thematics, change the colors. Here I've changed it to red. And so now the data is up on the internet, ready for people to download. So to show you how that would work, I'll come back into coordinates.com to the landing page. So I'm now a consumer of data and I want that OpenStreetMaps layer. So I can come in here and do a search for vineyard data. At this point, it'll go away and it'll search the entire Coordinates platform, and any data that it finds that has that vineyard information has been tagged in, it will find. This is the layer that I'm interested in, vineyard land use. I can click on this card and it adds it to the map. So the idea here is we want people to be able to find the data that they're interested in, do a full appraisal of it, and be able to download it to their own personal systems without having to call the data owner. So down here, you've got the about that I'd filled out. It gives you an upfront view of what licensing is associated with the data. You can check out what attributes are in there just to make sure it's the layer that you're looking for. And the other key bit in here is services. So once the data is on the platform, it can be accessed by API, by WMTS, a number of different methods. So for instance, developers, they can come down here, see what the pre-configured URL looks like to add this data to a map. This is quite a good use case for people that want to store their data on the platform and they don't actually have a shopfront for it. They just want it to be essentially a server of geospatial data. That's how Integrate operates. Just to give you an example of that, this is a ArcGIS online web map that is consuming that layer that I just configured as a WMTS service. So you can overlay it on your maps. People can consume it in that regard. Probably the most common way that people will want to consume the data is they want to download a copy of it, pull it into their system, do their bits and pieces with it. So from here, I can add it to a collection. This now makes it available for download. In the event that it was an enormous data set, you can come in and create a crop that's going to clip out the area that you have highlighted and zip that up and make it available for download. And then once you've got it all sorted out and you know that that's what you want to grab, you can come in here and hit export. Two options at the top. You can either download it as a file. If it was a mini gigabyte layer, you can have it couriered to you on a USB stick. I'll just stick with download. We support a number of features, a number of different formats. This is an important feature of the platform. We're trying to be as open as possible and feed into all the different ecosystems without constricting you to any one particular vendor. So we support PDFs, CSVs, KML. You can get it as a CAD file. I'm going to stick with GIS for today. Different formats of GIS you can download as an Esri shapefile, map info tabs, Esri file geodatabase, or a geopackage. I'll again just stick with shapefile. You can come in here and pick the projection that you want. We will reproject on the fly and then create a download for you, which I'll just leave it to the default. So that now I can click export. So that's all happened under the hood and it's now ready to download. So that's pulled that zip file down. Inside of there, we've got the shapefile that you wanted. So in not too many clicks, you've managed to locate the data that you're after. So that's how the platform operates at the present. I'll now move to where we're heading with this. What we've done is we've built a new distributed version control system. If you're familiar with Git, a lot of this will make immediate sense to you. It's by no means a prerequisite though. Key ingredient in the system is called Snow. It's been available it's been in production for a year, available from snow.earth. It's an open source project and it's a wrapper around Git. So it brings, what we've essentially done is we've taught Git how to understand geospatial data and tabular data. And you can do all the collaboration stuff that happens in the Git ecosystem with your geospatial data. So that involves stuff like creating branches, doing merges, pull requests, all the good Git things. When we first released Snow, it became obvious that geospatial people were visual in nature and they weren't necessarily au fait with the command line approach. So to plug that gap, we've built this Koordinates desktop app on the right. In Git land and Snow land, your data resides in a repository. The repository consists of all the different versions that have contributed to the building of that data layer. So using the desktop app, you can manage repositories that you store locally, push and pull them from the cloud, and other people can also collaborate on your data set. Another key ingredient is that Snow's built to work on Windows and Mac and Linux. And the default format that we push data around in is a geopackage. We chose geopackage because it is quite open. You can work with ArcPro on it. You can work with QGIS, FME, other flows. We also support a number of databases, Postgres, MySQL, SQL Server for multi-user environments. And then over on the left, we've made a few architectural changes to the back end of Koordinates to allow it to host repos, much the same way GitHub works, using the same underlying technology. So it's essentially standing on the shoulders of Git, leveraging all the goodness of Git and opening it up to the geospatial world. So just quickly here, I'll explain how distributed version control works in a Koordinates context. At the top of the tree is the Koordinates cloud, again, similar to GitHub. This is the one source of truth where all the data resides. You can have multiple users here represented by these 3 columns. They can be using different tools, ArcPro, QGIS, FME, and they can be operating on different types of working copies. The way it works is you'll use the app to navigate to the Coordinates cloud, do a search for the data you're after, then you do a get, which pulls it down to your local repository. Once you have it down there, you can operate on the data in the geo package using the tool of your choice. When you make commits, that pushes it back to your local repository. And then when you want to collaborate with the world, you can do a push, which sends it back up to the cloud where other users can follow along and add their bits and pieces. So I'll just jump out of here and show you how that works. So this is the Coordinates desktop app, the wrapper around snow. On the left, we've got local. I've already cloned this one down from the cloud and it's stored on my hard drive. I'll show you what a repo looks like. This is my home area. This is the repo. Inside the repo, I've got a geo package and all the data is inside of the geo package where I can go ahead and make changes to it and capture them as new versions. If I open up this card, this is a repo browser, shows you the data that's in the repo. From here, you can do stuff like create a new branch, do all your operations on the branch and then merge it back into master. This middle column shows all the versions that have contributed to the building of this repo. So I can go back to the initial creation of the data set and I can review what happened at that stage. I can look at all the different things that were added to it. Over on the right here, we'll give you a visual diff of what actually happened. So here I'm looking at a new vineyard that was added for Penley Estate, and I can see all the attribution associated with it. So let's open up a copy of ArcPro and do some edits on that geo package. The first order of business, this is Penley Estate. I've got, if I zoom in here, we can see that we've got the rows. If I turn the vines on, we've got all the different vine data in there. So the assumption here is that I have got, this is a new block 6. I've already received that block definition and that is now part of the repo. I have a consultant that has mapped out all the rows and they've supplied it to me as a shapefile. So if I drag this into the map, what I want to achieve is I want to add this new row data to my underlying vine row table. So to get that done, I'm going to fire off a geo processing task and I'm going to append the data from the shapefile into the underlying data set. So I select the rows data. I'm going to put it into the vine row table. Now in a perfect world, which I'm sure you guys have discussed at length, everyone's on the same schema, not always the case. So in this case, I've got to come in and do some field mapping. And then I just run this task. So that's going to copy the shapefile data into my underlying geo package. That has happened already. And so now if I come in and turn off everything, just to show you what's happened, that data has now been appended to my underlying vine row table. So if I jump back into the application now, what's happening here is the snow component is monitoring the geo package and it's looking for any incremental updates that might have happened. It's picked up that I've added 40 new features to my vine row table. So if I select those, again, down here, I get a visual representation of what exactly I've added. And I can see all the individual records that have been added here. So it gives you another opportunity to QA the work that you've done. Again, I'm doing all of this in my working copy. This process now is creating a commit, which is going to a commit point, which is essentially creating a new version within my repo of the data set. And so here I'll give it a name that makes some sense. So we're adding Penley. And if I hit commit, that adds it to my local repository. It will appear shortly as a new version underneath here. And I'm still, at this point, haven't actually pushed it anywhere near the cloud. It's just all existing locally on my own repo. I get an indication here that it's now, my local version is one copy, one version ahead of the Coordinates cloud. That's just to remind me that this is all happening locally. I haven't pushed it up to the cloud at all yet. Before I push it up to the cloud, there is one other piece of work I want to do here. And that is that I'm going to propose a new block 7 for Penley Estates. I'm going to do some edits to the vineyard table. I'm going to suggest that the new block exists here. Oh, won't let go of it. So now I've added a new block. I don't know what the actual attributes are for this block. I would rather that the vineyard owner themselves fill those in. So if I jump back into the app, I can see my new proposed block 7. I'm going to call it the proposed block 7 and hit commit. This is going to create another version of the data just below here. One of the other features is a Git thing. This is a cryptographic hash. Each of my versions will be assigned a crypto hash. I can now roll back and forth throughout the versions. This saves you having to download multiple versions and tag them 1, 2, 3. You have all the versions embedded into the same repo. So now if I want to share this with other people that are collaborating on the same data set, I can hit push. This is taking my repo and it's pushing just these incremental changes up to the Coordinates cloud, where other people that are collaborating on the same data set will now have access to the changes that I've made. So if I now cross over to Anne, who is today being the vineyard owner, she can fill out the attribution for the block I've created.
Oh, thank you. So can you see my QGIS okay there?
Yep.
Awesome. So if I'm the vineyard manager and I'm working in QGIS, which is a free and open source GIS software on my Mac, Eli's working in on Windows system using ArcGIS Pro, and right here I've got the OpenStreetMap as a base map, and this is the vineyard data that Eli was working on before, and this is what I had already downloaded to my machine from, say, yesterday. So how I would start working is I would jump into the Coordinates app, and I've got the vineyard data set open here already, and I want to see if anybody's been working on it overnight or in the last few days. So all I have to do is hit this button here and check for updates, and that's going to make a call to the Coordinates cloud and check if anything has been going on, if anyone's made any changes. So I don't need to have had any conversations with people beforehand. As you can imagine, there could be quite a few people editing and collaborating on a layer. And when that comes through, sometimes it takes a little longer over Zoom. Here we go. We can see the proposed blocks that Eli has added. He's done 2 things since I last looked, and I'm able to have a little QA and a check. And I see he's only done it today. It was 4 minutes ago, and they are a change or they're newly added because it's green here. So I can see that's all new data that he's added, and that there's 2 commits ahead on the Coordinates cloud. So looking at that, I'm happy that they look great, and I want to apply these updates to my, why is that frozen? Apply these updates to my local copy. For some reason, my screen's frozen. My app's frozen. live demo. So what I would do, here we go. Wow. So I would pull those updates down and they would appear in my machine here. Unfortunately, I've just had an issue and yeah.
Well, Anne, we'll just let you, if you just have a, I'll just sort of cut in a bit because it's a sort of a quick question.
Oh,
You're
cool.
obviously, you there? Okay,
Oh,
fab.
yes.
If you just do that. I had a question because obviously like you're using QGIS and a part of what, you know, like one of the challenges like Lindsay said at the beginning of this is like, how do we find a way as a wine industry to kind of have a system kind of process approach where all different people, all different actors in our industry might be using all kinds of different types of software and tools and apps, but how can we create a structure that allows us to kind of like build towards like interoperable important layers like block boundaries? So you're using QGIS here, and which is obviously quite specialized software, and there'll be some vineyards that are quite tech orientated that use this kind of, you know, would use ArcGIS and QGIS, but like, would this actually work? You know, if this was me as a, you know, as a vineyard manager and I was making changes on like AgWorld as like a tool that I use, like, is that theoretically possible to also hook into this system?
I could probably address that, Ollie. I'm not sure how I get my video to actually turn up. Maybe unshare your screen and quickly.
Oh, and it's just started working, but
Oh, it's
I'm
working.
sharing.
So
Yeah,
get back to the demo, Ollie. It's more exciting anyhow than me talking. We'll do the demo. Okay.
Okay.
We'll talk, I'll answer the question after this, Ollie.
Awesome. Thanks for that. So it has now applied that copy, that change to my local copy. So I would jump back into QGIS, and what I did just to check that it had come through properly is I clicked just the refresh button, and this new block has appeared here. So I, being the vineyard manager, I want to attribute this block because it looks fantastic to me. I'm happy with that shape. And I'm going to give it a name. I'll go with the Moroccan theme that we have here and call it Marrakesh. And it will be owned by Penley Estate. And it is on McLean's Road. Cool. So now I've saved those changes that I've made, just a slot here to this new block that Eli added in 5 minutes ago. And that's all saved. So I will jump back into my Coordinates app, and it's immediately picked up that there's one uncommitted edit to my data set. So I then have a look, and you can see it's orange now, which means that I've made a change to the data. I haven't deleted or added anything new. And I want Eli and everybody to know that I have now named the new block. We'll call it block 7. So it's now official, and I'm happy that I've added, and it gives me another little chance to do a QA and make sure that I've got the correct name, owned by, and all the attributes are in there, look good. So I'm going to commit that change. That's then going to bring it to my local copy, and will give me another step of QA and checking before I then can push it up to the Coordinates cloud. So this is how, here we go, and then there it appears here. We can see my copy is now one commit ahead of Coordinates cloud, and again I'm able to have that little QA step to have a check, and it's now added this cryptographic hash. So if we did want to roll back to my layer in say 5 years time, they wanted to know who named it and why, all that is recorded in the version. And I'm happy that all looks great. So I'm going to push this commit, and that's where we're going to take it from my local system and push it up to the cloud so that everybody who has access to this layer is able to use it and see what I've done. So I'll stop sharing at that point and hand back to Eli to show what happens at the other end.
Cool, thank you. So just to close the loop, finally, if I go check for updates, it's going to begin query the coordinates cloud, and it will see that Anne has made a change. The change comes through, I can review it. I see that she's done exactly what I was hoping she would, which was name the attributes for this. Again, it could be a number of different changes. If I click apply updates, that's now going to pull that change down into my repo, assign it, and I can jump back into here. And I can go into my vineyard table. And see that the layer has now been named. So that's effectively allowed us to communicate and collaborate without having to email stuff to each other at all. So just to summarize where that's left us, I've pulled it down from the cloud. I've done some changes. I've pushed it back up. I'm using Arc Pro. Anne's pulled it down. She's made her changes in QGIS and pushed it back up. And then it's allowed us to sync our data set between the two of us using different operating systems and different GIS software, which solves, we hope, a number of problems for the world. So yeah, I don't know if you want to address that question,
Ollie, would you mind restating from, I think you were asking essentially how you propagate geospatial data into different systems and then, return the edits from those systems back into a shared access sort of situation, but in which the owners of the data remain control. Is that
Yeah, just where you left that was, it's almost, that was quite informative, just where you finished, Eli, that, yeah, like you obviously were collaborating with Anne there, and the changes she was making were propagating into kind of your world. The thing that, from the grape industry side, we're looking at ways where those changes, just looking at people, like, could get propagated into something like Deep Planet or our own startup platform. So like we would be able to pull in those updated block boundaries once a kind of an authority had said, okay, that's actually where it's at. So, I'm planting a new block this year. As soon as I've planted it, it kind of feeds, all these apps that I've given permission to have my blocks, they all then will receive the updated block boundaries. That's kind of the use case that we're looking at from a wine industry perspective.
Yeah, and it's very similar to software development. I put a little comment on the chat actually for those who are following chat. That's exactly the design goal. What we've skipped through a lot of the things we can already do, and then obviously we haven't mentioned any roadmap things. But on Eli's last slide, it had a brief mention down the bottom right of a relational databases. So Snow can already flow changes into and out of any connected relational database. So that's Postgres, Microsoft SQL Server, and then MySQL in a week or two. And obviously that adds a whole bunch of capabilities into freely, getting edits into and out of apps that anyone may be running, but also databases that are being controlled by desktop GIS software, for example, or automated data changes from machine learning outputs, for example. And it's pretty powerful when you combine it with having branches and then someone being in the role of moderating which branch gets merged, and then everyone else can sort of access the changes when they need them or when they decide they want to apply them. And of course, this all supports offline working as well, and API access, depending on what your app and how it's built. And I probably shouldn't talk too much. Oh, there's some questions. I'll scroll down. Yeah.
If you could, I don't mind picking up the questions on the chat, Ed, or we'll pick it up with the time we have at the end.
All right.
But obviously there might, in terms of people picking up with you guys after this, it would be great if you don't mind. We'll just circulate your details out to everybody here.
That's great. Yep.
Yeah, so please feel free if this kind of looks interesting. It's something that we're keen to potentially explore, and still lots of questions to kind of work through so that we can kind of validate that it fits the wine industry. But like you're doing some really, really interesting work, and thank you so much for spending the time to share it with us. And yeah, hopefully this can solve some of the challenges that we're currently facing in the industry.
Yeah.
And with that, thank you so much. I will hand back to Lindsay.
Okay.
Thank
you.
Thank you.
So one of the outputs from the Collabriculture project is the logical data model, which Ollie was supposed to put up for us. But you did see when Eli was pulling through, the data and he was updating the schema, those are the database tables that we're trying to identify. So that way, when you're pulling data in, you don't have to drop any tables. We all kind of know what we're working from, or you know how you can match them if you've named them something differently. So that's one of the foundations of that, taking that thinking out of it. So we've published all of this onto GitHub, and John has done a walkthrough video, and we're sharing the links to that in the chat on Zoom, and we'll circulate them after. One of the objectives was to create standards around mapping, global applicability. And so we're joined next by Matic and Ian from Vineyards, and they've stayed up very late from Europe to let us know what's happening there and how we can continue to collaborate with them.
Yeah, hello. Thank you for the introduction. Just one thing, I don't have the right to really start the video at the moment. Oh, I have it now. Yeah. Okay. Let me try to share the screen as well. Thank you for this very interesting presentation. Yeah. From Koordinates. Can you see my screen?
That's all great. Thank you, Matic. Sorry, a bit loud.
You can see it. Yeah. Okay. Thank you. Perfect. So yeah, my name is Matic. I'm coming from a company which stands behind the Vineyard software. And in the next about 10 minutes, I'll try to speak a bit about how we got involved with Collabriculture as a company from Europe, from European Union, which is working closely with the UK-based vineyard, Jojo's Vineyard, with Ian, who is also on this call. And yeah, hopefully give some idea. So first, who we are a software company focused on basically serving our vineyard management customers with software solutions for their everyday problems. We provide basically a cloud-based vineyard management software called Vineyard. We started 7 years ago, and while our strongest customer base is in a few European countries and California at the moment, we actually have customers all around the world. And over the years, Vineyard grew into a very, I would say, complete vineyard management software suite with tools to optimize various aspects of work management, such as reporting, planning, and so on. As well as we are really focused on supporting also precision viticulture practices with the software. So Vineyard also provides different data visualizations and modeling with sensor data, maps, and other digital data. And yeah, often, particularly with the bigger customers, there is always a need to connect the software with some of the systems that they use or that they have in the vineyards prior to implementing our solution. And this is how we learned really firsthand how exhausting it is to negotiate and build integrations over and over to basically connect with the existing systems which are there on the ground. We have right now at this moment compatibility with more than 30 different types of devices, from weather stations, various sensors, actuators, trackers, and so on. But over and over, then the new ones pop up, and we need to integrate to basically deploy the solution in some of the bigger customers. And so we started looking into the activities for standardization of those integrations. And this is how we got involved with ATLAS project in Europe. So ATLAS is basically an EU-funded project that is aiming to improve interoperability between different systems on the farm. It's funded from a large European Union framework, which is called Horizon 2020. And it's a project with stakeholders from the whole Europe, really. And now the goal of ATLAS is to build a network of services which are following certain so-called service templates, with ultimately the goal to make different solutions speak common languages in their domains. So the picture of the project is very broad. It includes services from permanent crops, arable farming, livestock farming, and so on. But our involvement in Atlas is really focused on the vineyards. So our company really works in the area of defining those things for the vineyards. Now, what we are doing inside Atlas, if I dive a bit deeper, but I won't go really deep. So what we're doing is actually an extension of the activity that we have together with Ian and Jojo's Vineyard in the UK, where we are working on a solution to really precisely, down to the level of a few centimeters of accuracy, we're trying to map Jojo's Vineyard vine by vine and generate a true and precise, basically, digital vineyard picture. And of course, once we get the concept proven, the idea is that we can map also other vineyards as well as, address them with our software solution. Now, inside Atlas, the role that we have is really focused on defining the interfaces for vineyard map data between the solutions. So we will eventually be able to share the precise map that we will generate with other services and products that may use this precise map data. And we need to define those things in a standard way. And this is how we basically, through research of the topic and interesting discussions with various people, and really kudos go to Ian here, this is how we learned about Collabriculture project. And yeah, this was a great thing because it was just in time. We were just defining the data structure on our site, how to save all this data that we are generating with the mapping component. And so that, like, bam, there is an open source project doing just that, which is trying to eventually build a consensus around how the data should be structured. And on the previous meeting, we also saw that there is a couple of companies interested in this data and working on this consensus. And this was exactly what we needed. So exactly in line with what we are doing in Atlas, trying to find also a consensus about how to structure and then share the vineyard data. So yeah, what we did was we decided to use that database structure of Collabriculture and base the interface which we are defining in Atlas on that particular data structure that Collabriculture defined. And that way, we believe that both projects, so Collabriculture and Atlas, not only got aligned, but all of the work which is being done inside Atlas here in European Union and there in Collabriculture in Australia is exactly is actually getting aligned on a common data standard. So yeah, it's a very interesting thing. So yeah, to conclude. This is why we actually believe strongly in the open source approach of Collabriculture. We believe that it's the way, if we want to define common technical language, if I may call it that way, the open source approach is the right one because it's easy to join and start using this work that is being kind of done for a tech company. And we really felt also that experience on our own skin because from the initial discussions up to that moment, there is like, I don't know, maybe 1 month has passed and there is something that has already happened. So we also believe, that additional types of data should be added in the future, or that would be a very interesting direction to go beyond just the vineyard structure. So things like how to describe, for example, the activities that were done in the vineyard, such as spraying. So there is plenty of space for the story to evolve. And I guess that would be it. If anyone wants to chat with us on the other side of the planet, so please feel free to shoot us an email. And thanks for the attention.
That was so great. Thank you so much. We'll keep pushing just for time. So with this last session, we're finishing by looking at the principles around data ownership and governance structure. So we couldn't think of a better person than to bring in Andrea, who led the creation of the Australian Farm Data Code. And this code was created by the National Farmers Federation, and we're proposing that it could be a fit for the future of data in the wine industry. So I've got here, please ask Andrea questions as we go, but we are running short of time, so we might have to follow up with her after. But Andrea's also been on her own journey around an open source approach to technology, specifically around soil and soil tech projects that she leads. So she'll share some insights and some learning from that as well. Thanks for taking the time to be with us today, Andrea.
Andrea, I'm going to be the voice of God. And if you don't mind just sharing your screen for us, we should be able to bring you up now.
Okay.
That's perfect.
There you go. Have you got that one?
Perfect. Great.
And I'll just put it on the big screen.
Thank you.
You good?
Yep.
I don't know why that's
All
there,
good.
but anyway, we'll get rid of that. Okay. So hi, everyone. How long have I got? Have I got 10 minutes? Is that right?
What about, yeah, 10 minutes would be absolutely perfect. Thank you.
And then we're going to have a bit of a chat because I'm going to pose some really big, meaty questions at the end. So thanks, Lindsay and Ollie. So thanks so much for inviting me. Yes, I am here with a couple of hats on, mainly with the NFF hat, the chair of the Farm Data Code, or the Farm Data Working Group, which led to the Farm Data Code, which I'll talk mostly about, but also with involvement in this soil tech project. So this is a land care smart farming partnership that my company has the overall kind of project direction and project management of. And what we're doing is to take University of Sydney soil science, put it through an agile development process with a startup called Farm Lab and an agronomy firm called AgriVision, who are based in Victoria, and to create a set of tools which can be used by land managers to manage soil better. And what the capability that's come out of that is the ability to create soil maps at farm scale or paddock scale. And my colleague in that effort, Kip Crossing, is also here today, and Kip's the technical genius. I'm just the kind of project manager, but Kip is also a true convert in, or a true kind of believer in, and has a lot of deep understanding around open source, and he's bringing me on this fantastic journey. So we'll swivel back to that later. So then in terms of, how do I get to the next slide? No, it doesn't want to do that. Why is it not moving forward? There we go, got it. Okay, so yeah, the Farm Data Code. As Lindsay said, I am on the board of the National Farmers Federation, and I'm now chairing this Farm Data Working Group. And that came about because of a big piece of research that was done back in 2017, which was called the Precision to Decision Project. And there was a number of reports that came out of that. And one of them was looking specifically at the legal dimensions of digital agriculture in Australia. And, you know, one of the things that came out of that was that they found that farmers were very concerned about the privacy and the security of their farm data. And so this was a big issue, and one of the recommendations of the report was that we needed to do something about this. So the recommendation was actually that National Farmers Federation, as the peak body for farming organisations and farmers in the country, would step up and start to address this. So we formed the Farm Data Working Group in 2018, and that's made up of, you know, member organisation representatives, farmers, technology service providers. And what we've done was to kind of tackle this issue. And the low-hanging fruit was really the development of this Farm Data Code of Practice. Now, the Kiwis in the conversation today will know that, you know, you guys were way ahead of us on this, and as was the US and Europe. So Australia has been late to come to this body of work. And in some ways, that's not so bad because we've been able to learn from some of these other jurisdictions. And so we launched the Farm Data Code in February of last year just before COVID hit. And it's really low-hanging fruit, I have to say, in the sense that what it does is it specifically applies to entities which have a direct commercial relationship with a farmer and which collect, interpret or manage data in connection with that relationship. And the reason for that is because really the only area of law which actually gives farmers any kind of rights over or control over what happens to their data is through contract law. And so that's where there's an agreement between the farmer and whichever organisation it is that they've contracted with to collect data through technology, manage, share, use data. And the way in which that control is enabled is through the contract itself. And so what the Farm Data Code is to set out a set of 7 principles around the sorts of questions that farmers can ask, and also that we encourage service providers to respond to in their data usage policies that then get transferred into the contract or the contractual arrangements and the details in the contract between those two parties. So that's what the code addresses. It's one data relationship. There are many, many other data relationships that farmers have, many that they don't even know about, that this code does not cover. But we had to start here because that's the kind of firm legal ground that we've got. So I'm not going to go through it because I'm assuming that you've been through it, and if you haven't, that's fine, you can go through it later. And I'm always happy for people to contact me if they've got questions about it. But really it's a discussion document to get that, that awareness going, and for farmers to have something that they can use when they're negotiating with service providers around how their data is being used. So I just wanted to spend a couple of minutes going through the bigger picture here and raising some big, hairy, audacious questions. So the first one is, farmers are farmers and they're not lawyers. So this is a contextual thing. Really farming in Australia is a sector of small to medium businesses. We've got about 63,000 businesses. Most of them are actually small and medium businesses. Most of them are actually family and multi-generational family businesses. And a lot of business is still done on a handshake or based on a brand relationship. And a handshake is a contract. If you've shaken hands, even if you've just had a verbal discussion, that's a contract. So farmers need to become not only aware of how their data is gathered, used and shared, but also about the legal aspects around that and what a contract actually means and what it entails. The second piece of context is that we now live in what I call the post-privacy world. And, that all kicked off with kind of, it came into better awareness around the Cambridge Analytica debacle that happened a number of years ago. But, if you haven't already, I would really encourage you to read Shoshana Zuboff's book, The Age of Surveillance Capitalism. If you haven't already, then read watch The Social Dilemma on Netflix. All of these kind of aspects about this post-privacy world are now coming out. We've got the platform media wars going on, although they seem to have kind of come to some sort of arrangement over the last little while between the Australian government, Google and News Corp. So we've got all that going on. But these issues are largely being fought out in the space of consumer privacy. And we haven't even really started to talk about what post-privacy means for business, let alone what it means for small businesses, let alone what it means for family businesses. And what does it mean for farmers? So this is another context that we need to bring to this. Add on top of that, agriculture is unique in the sense that it's largely a geospatial industry. And that's what you guys have been talking about. And it's a fantastic discussion. So it actually is the most open and exposed industry. In my view, from that sense, we've got multiple eyes in the sky. We are the most viewable and the most viewed and surveilled industry. And that's been going on for a long time, but it's kind of with Leo's coming on board and all that sort of thing, it's now undisputed that we are the most viewed industry. And I'd add to that digital twinning of farms is largely a third-party affair right now. So all of this surveillance is leading to the case where we're doing really smart things, including what we've been talking about today, where we can gather all of this often public data and do smart things with it. And we can create digital twins of farms without the farmers even knowing that that's happened. And added to that is that we're now in this era of transition. We're going from the analog world to the digital world. And I think this picture really kind of sums up nicely, to a world where we're fully connected. And, you know, if you have the frustration of not being fully connected on farm right now, it's coming, and it's not far away. To digital twinned everything, not only farms, but and you know, devices or mining companies or whatever, but also human beings. And we're also now in this journey from proprietary to open source, and that's a fantastic thing. And so that's the conversation in the group that we're in right now. So the big questions that I have in the context of all of that in this new digital world is, how can farmers retain agency over their business when their business becomes everyone else's business? What is Australia's agriculture competitive advantage in this new digital world and within this new digital paradigm? What is in the national interest? And this is something that the federal government has suddenly started to wake up to in the context of COVID, because we suddenly had issues in our supply chains. We couldn't get fertilizer from China. You know, there was all sorts of supply chain issues that started to bubble up during COVID for agriculture. And the Australian government's gone, oh, hang on a minute, we haven't looked at that before. And so the Critical Technologies Policy Coordination Office is now looking specifically at agriculture, and they're currently seeking, they're consulting and they're seeking input. So I'd really encourage you all to have a look at that and to put your views in. And then what must we do in a post-privacy, digitised world to ensure that farm data collection, aggregation, use, sharing leads to win-win-win for whoever is involved in that process, but including the farmers? And so these questions, we're not going to be able to answer them today, but these are the questions questions that I want to pose is, what open source models can we develop and adopt that support Australian agriculture? I think you guys are already working on that, and we're working on that in the Soil Tech project as well. But then how can open source projects simultaneously deliver new open source technologies and systems and provide a competitive advantage to Australian agriculture in the context of that post-privacy world that we live in, and particularly when they're being publicly or industry funded? And I'm really aware of that, because the Soil Tech project is $1 million project, and that money's come from the Commonwealth. And so I'm really conscious that we need to grapple with some of these issues in order to provide a return on investment for that funding that we've been given on behalf of the Australian public and the agriculture sector. So there you go. I've just thrown out some really big meaty questions, and that's what I had. So Ollie and Lindsay, back to you.
I have a question for you, if that's okay. Obviously, with your Soil Tech project, you were right in the midst of this kind of thinking through publishing things in open source repositories, and you've also got your kind of farm data code hat on.
Yeah.
And you know, like, one of the questions to think of is like, yeah, like, under what licensing should things like block boundaries be published in vineyards? And like, how are you thinking from the Soil Tech project about how you publish things, under what license, and how it might fit into the data code and things like that?
Yeah, we haven't actually answered that question yet, but we've raised the question, and we're looking at all of the possible licenses, from, you know, Creative Commons to MIT to, you know, GPL, all of those different aspects. And that's a question we're actually taking back to the Commonwealth for discussion, and particularly to the IP Commissioner, because we're kind of forging new territory here. There's not many projects like this where we've taken science, where science has been translated into a set of open source code and tools. And so we are forging that new territory. And so we're taking all of those options back and saying, well, here's what we think might work in this context. But we need you as the funder, and really as the government, to say, well, yes, you know, and in the context of IP, in a policy perspective, to be helping us to work out what the answers to that are. And so we'll probably end up, I mean, the intent is that we end up with something that means that anybody can pick up these tools or the code behind these tools and use it. and take it off and do something with it. And, you know, what we're trying to get to is where we've got a set of code that's got a really a fundamental basic kind of capability that it provides, and that startups, existing platform providers, whoever wants to can come along, pick up that code, and then turn it into some application that works for in their target market. So what I'm wanting is for 1,000 flowers to bloom out of this. And so again, the licensing has to enable that. But at the same time, I'm wanting to make sure that there's some consideration given to the privacy of the farm data that now becomes potentially very public. And so one of the things we talked about was possibly making that license subject to a clause which makes it subject to the farm data code, so that the farm data code becomes a reference point for service providers building new applications, so that at least they think that through and that they have a data usage policy which can be discussed by their end user. Sorry, that was a really long answer, but you know, there's a lot of complexity in that.
Yeah, no, that makes a lot of sense. So essentially, if you, you know, if you want, you know, if for example we wanted to use the some of the soil tech project, yeah, we would basically, you know, as I start with my startup hat on, we would be signing up that we are basically going to adhere to the farm data code, and yeah, that's kind of a part of being able to get the benefits of that open source technology will be that you are made aware of this code, and you know you're kind of following it essentially.
Yeah, that's right. And one of the reasons for that is because I'm a soil nerd from way back, so I'm a soil policy nerd, and that's one of my kind of deep knowledge spaces. And I'm really very much aware that soil test data is proprietary data that belongs to that farm. You know, surveillance technologies can give you all sorts of other data about farms, but right now it can't give you soil data. When you go down 10, 20, 30 centimeters down or meter down or whatever, the data that comes back is it's accurate, it's specific to that point. And in my view, that is kind of the secret sauce or the asset of the farm. And so now that we're making it really easy to take that data and to triangulate it with public data models, you know, publicly available data models for that particular paddock, and then take the learnings from that and extend it across the paddock, that means that you've now got deep data about what that paddock is about. And in my view, we're kind of crossing a line there, and we're starting to cross a threshold where, you know, that should not be publicly available. That should belong to the farm. And so, you know, it's not perfect, but the only way that we've got any way of kind of putting a boundary on that right now is the farm data code, unless anyone can tell me another way of doing it, and I'm all ears.
I'll just pass over to Lindsay, but that's a great way to finish it. And again, I think she'll touch on this. This is like these questions that we do want to, well, actually the questions we were wanting to ask as a part of this project is what actually makes sense to kind of go into the commons and what is absolutely proprietary. And like you said, there can be tons and tons of unexpected consequences that can occur to farmers through their data through certain proprietary data becoming public. Yeah. So definitely with the finance sector and etc. So yeah, we've got to be very conscious of it. But thank you, Andrea, for wrapping that up so well. And over to Lindsay.
Great, thanks so much, Andrea. So that does wrap up the last of our initial series of workshops. We want to thank PIRSA for their support in making these happen. Over 150 of you have contributed to these, so thank you everyone that's participated. We're really excited to see a community forming, and we're really keen to continue the momentum. So we'll send you a follow-up email next week asking what you'd like to see happening next, and whether or not one of your team would be interested in being actively involved in maintaining our GitHub repo. We've got John Bryant, our GIS lead, on Zoom. Maybe he had a hard leave, but we're really happy to answer any questions and take your feedback. So we'll keep Zoom open for anyone that wants to continue discussions there, and everyone in the room is welcome to stay for a coffee.
Yeah, and I just want to say a last massive thank you to everybody, all the team at Coordinates who joined us from New Zealand, and it's great. Again, this project sort of had its own little life, and yeah, it was through ag tech people in New Zealand picking up that we were doing this, that we got to know them, and then again, different connections we have in soil that got us to meet Ian Beecher-Jones, who's a part of the Vineyards team. So thank you to them for staying up until midnight, and again, just to kind of close a few loops that have happened along this journey. So we've got Peter here who represents the OIV organisation in Australia, and one of the things that when he spoke early on was about like how can we join the dots with things like the Atlas project, and because we're taking a practical first step here in Australia, like we are able to actually provide like some value to like these massive projects in the EU, and we have a chance just at the moment to be like not just on the receiving end of standards that are going to hit us, we have a chance to be kind of right at that top table. And yeah, Matic's brought that completely to life by just basically being able to go up there, present it to everybody. It like nobody's got any objections to it. So as a community, we've broadly got it right. So thus it's going to be taken on. So like these are really important first steps that we're taking, and I don't think like we should underestimate the importance of these first few things that a group of 150 of us have done. So thank you so much.
Thanks, Ollie, from over here in Coordinates. Really enjoyed it.
Okay, so yeah, please feel free to ask any questions. Like Lindsay said, we'll send this follow-up email next week with and we'll also share Andrea's questions that she posed out to the audience. And yeah, like we've got some ideas for if we can run some future workshops, what we might want to cover, things like how to survey vineyards really accurately and get under that, get into things like where positional technology is going as well. And so any other thoughts you have of where we might take things if we can run some future workshops would be great as well. So you'll hear from us next week. And